Welcome to the absolute value equations notes. You should have the first half filled in. This video is mainly for people looking to finish off the notes. There is another video on my channel that has one that does it all. So just a real quick glimpse. There are three main steps in solving equations with absolute values: isolate, split, and solve. Isolate the absolute value. Over here, we did that by getting the absolute value all by itself. Over here, the absolute value is already all by itself. It's okay if there's still stuff inside, just not outside. Split it into two equations. Notice how this one was already alone, so we did x minus 3 over 4 equals 6 and negative 6, because that's saying that this is 6 away from 0, so you need 6 and negative 6. Because you could go to the left or to the right. And finally, solve. Okay, let's talk about these examples down here. I want these absolute values to be by themselves, so I'm going to do two things. I'm going to subtract 4 to the other side. That gives me 3. And then I'm going to copy down the rest of this, and I'm going to divide by 2 to get rid of this number out front. So this is really 2 times the absolute value, meaning the opposite of division or multiplication is division. So we're going to divide to get rid of that 2 out front. Now I have the absolute value of x minus 3 equals 3 halves. That means that x minus 3 can either equal 3 halves or negative 3 halves. And I need to add that 3 to the other side to get x all by itself. That is just regular old solving. Then I'm going to cross out that 3 and rewrite it as 6 halves so that I can do 3 halves plus 6 halves. 3 and 6 halves are the same thing. 3 halves plus 6 halves is 9 halves. Same thing over here, but negative 3 halves plus 6 halves is positive 3 halves. And there are my two answers. It is okay to get a fraction answer, y'all. Last one on this side. Got to get these absolute values all by themselves. So we're going to add the 4. 14 plus 4 makes 18. And then we divide by 3. (18) divided by 3 is 6. This means that I have this equation and 2x plus 8 equals negative 6. Subtract the 8. Notice how I'm doing the same thing on both equations. Over here, 6 minus 8 is negative 2. And over on this side, negative 6 minus 8 is negative 14. And then I'm just going to write this, divide by 2 as your last step, and your two answers are going to be negative 1 and negative 7. I'm not trying to focus too much on the actual solving part. It's just to say, once the absolute value is by itself, it either equals positive that number or negative that number. But watch out for extraneous solutions. We'll talk about those on the back side. Here we go. We're flipping the page. All right. So there are two possibilities of like some tricky situations that occur with absolute values. Issue number 1 is no solution. The absolute value itself, and I'm just gonna like put a scribbly line in there. So this is the absolute value of something cannot equal a negative number. So no solution is if you have an absolute value equation like x plus 4 that equals negative 5. Can't equal a negative number. So this is from the get-go. You'll be able to see that you have no solution because there's a negative number on this side. Extraneous solutions are equations that can be solved, but one or both of their solutions could be extraneous. Extraneous means that when you plug the answer back in, the answer doesn't work. when plugged in, or I'm just going to say when substituted, because they make the absolute value equal a negative. Now you might be like, isn't that the same thing you just said? Kind of. The issue is, like on these two we can already tell whether or not they equal a negative, but when we get down to things that have the variable on the other side, if x was 1, 8 minus 2 is 6, that would be fine. But if x was, say, 5, 2 times 5 is 10, 8 minus 10 is now negative. So certain values of x would make this side negative, and then it breaks the rules. But there are also some values of x that could work. So we don't know automatically whether or not it's a no solution. However, on this first one, the absolute value of 4x plus 7 can't equal negative 3. Here's the easiest way to catch this. If you were to try and split up this equation, you would have to turn the negative 3 into a positive 3. It should always be making the number negative, not turning it back into a positive. This one is no solution because absolute values always equal a positive number, and that's a negative 3. Over here, though, be careful because it looks like it's negative 3 like the last one, but you can only tell once you've isolated the absolute value. So we've got to get the absolute value of 4x minus 13 by itself. And when I do that, now negative 3 plus 10 is 7, which is totally, completely fine. So now I need to solve 4x minus 13 equals 7, and 4x minus 13 equals negative 7. So don't always assume at first. I'm going to add 13 to both sides in both equations. I'm working smarter, not harder. Whatever I do here, I'm going to do here because they're the same equation. One of them just has 7 and one of them has negative 7. Negative 7 plus 3 is 6. There we go. And then we're going to divide by 4. 20 divided by 4 gives me an answer of 5. And 6 divided by 4 gives me an answer of 1.5 or 3 halves. If you wanted to simplify this fraction yourself, you would simply divide them both by 2. Moving on down, we've got to isolate this absolute value. So I'm going to subtract this 8. 3x plus 4, absolute value, equals 4 minus 8 is negative 4. So while this one started out looking fine, now we've got a negative over here, and that is no solution. And I forgot to box this on the one up there, but that is the full answer. Go fix that. There we go. Now let's talk about what you do if there's some extra stuff over here. So the absolute value is by itself, so that's good. But this is the side that you need to split. Here's how we split it. First of all, one of them stays the exact same way, just without the absolute values. And the other one changes the sign of the side that doesn't have the absolute value. So I'm going to change them both. The 8 is going to become negative 8, and the negative 2x is going to become plus 2x. So I'm multiplying this whole thing times negative 1, basically. So if there's multiple things on this side, you make the whole thing negative. Now for both of these equations, I need to subtract this 4 to the other side. Notice how I'm lining it up underneath the 8 and negative 8. I can't subtract it from 2x because it doesn't have an x. So make sure you're lining up your like terms. 8 minus 4 is 4. Negative 8 minus 4 is negative 12. And this is where they do become a little bit different for a second. I need my x's all over here on the left. So I'm going to add this 2x over, and I get 3x equals 4. And over here, it's a positive 2x, so I have to subtract it. And by the way, there are those imaginary ones in front. That's how I got 1x plus 2x is 3x. 1x minus 2x is negative 1x. And then I need to divide by 3 and negative 1, respectively. Okay, so those are my answers. Now, if you have variables over here, you need to check them. But again, the thing that we're worried about is outside the absolute value. We need to make sure that this side isn't a negative. So I'm going to check 8 minus 2x. 8 minus 2 times 4/3, and 8 minus 2 times 12. And I'm just going to go ahead and do this in my calculator, and I will go ahead and pull it up and show you. 8 minus 2 4/3. That's a positive 5.3, so that's fine. 8 minus 2 times 12. There we go. Okay, that's negative 16. Can't see that. There we go. Negative 16 is not okay. So this one is not actually an answer. What I want you to do is leave it on there, but cross it out like that. So I can see that you got an answer of 12, but then you cross it out afterwards. All right, let's talk about the last two really quick. 4x plus 10 is already by itself, so it equals 2x minus 6 and negative 2x plus 6. So you still do the opposite, guys. If you're asking me which one you do the opposite of, it's both of the ones on this side. And then I'm just going to solve each one from here. Subtract that 2x so it joins the other x's over here. 4x minus 2x is 2x. Keep the plus 10. These two cancel it out. Equals negative 6. Over here, it's already negative 2x, so I'm going to add that 2x. 4x plus 2x is 6x. Keep the plus 10. That crosses out, and it equals positive 6. Then you get rid of the 10s by subtracting them. Notice how I am going in a slightly different order on this one. That's fine. Negative 6 minus 10 is negative 16. 6 minus 10 is negative 4. And then you just got some division left. Divide by 2. X equals negative 8. Divide by 6. X equals, I can reduce this fraction by dividing the whole thing by 2. Negative 2/3. And then we need to take those two and check them on this side. So the 2x minus 6 needs to be checked. So 2 times negative 8 minus 6, and 2 times negative 2/3 minus 6. I'm just checking it on the side that didn't have the absolute value, because this absolute value can't equal a negative over here. Okay? So let's double check this in my calculator. 2 times negative 8 minus 6, negative 22. 2 times negative 2/3 minus 6. My calculator does that in kind of a funny way. Negative 7 1/3. Guess what, guys? We did all of that work for no reason, because this one ended up having no solution, because they both canceled out. Okay. I'm going to go ahead and pause there. I'm going to write out my work for this last one, but I'm not going to necessarily say it all out loud. That way you guys can see the last problem without wasting all of the time of me explaining it. Go ahead and start working on your assignment if you want to. And I got -14 and -2/5. Again, I'm checking that on this side over here. The 3 times that number that I got plus 8. And then I'm going to check them both in my calculator. 3 times -14 plus 8, -34. That's a negative, guys. Nah. 3 times -2/5, or -2 divided by 5, plus 8, positive. So that one is fine. Good luck on your assignment. Don't forget to work on 1.7 also.